Welcome to the lecture 5 of this Python programming course. Today we will start the collection data types. We have already seen the fundamental data types in our previous lecture. We will today start with the collection data types. So let's get started. So when we discuss the fundamental data types, if you can figure out the basic point in the fundamental data types is that we are only storing single object in a variable. If I declare a is equal to 0 like this, or let's take a is equal to 10, so here I'm storing a inside, I'm representing 10 using a, which means that I'm only representing one object using a. So if I take a movie name like this, then I'm going to represent only one object. Okay, the object name is Iron Man, and I'm representing using the variable name called movie. So here we are only using one object, we are only declaring variable to represent one object, but the collection, these are called the fundamental data types. What these data types are: integer, float, boolean, string, and complex. So these 5 are the fundamental data types that we discussed. All these data types only store one object. Okay, so now in this lecture we are going to deal with collection data types. Okay, the definition of the collection data types is, if we want to store, okay, if we have a requirement to store more than one object, if we have a requirement to store a group of objects using a single variable, then we can go with this collection data types. So the definition is, if we want to store a collection of objects using a single variable, so then we will go for this collection data types. So if I have an object like this, so and we have so many objects inside this collection, we could have any number of objects, and we are representing using a variable name. Let's take this as a numbers. So we are representing a lot of objects using this numbers variable. So to represent a collection of objects using a single variable, then we will go for collection data types. So we have list, we have tuple, and we have set, we have dict, we also have a concept called frozen set. So these are the main collection data types in Python. We also have bytes and bytes array, but we will discuss that in our next lecture. These 5 are the most used. I would say list and dict are most used, but these 5 are the main collection data types that we are going to discuss, and we will also discuss bytes and bytes array in the upcoming lectures. So let's get started with list. So list is one of the collection data types. The definition is similar that we discussed before. If we want to represent a collection of objects using a single variable, then we will use the list data type. Okay, so I'll write the definition. If we want to store collection of objects, or I could say values, using a single variable, we use list. So list is a collection data type to store a group of objects. So what is the notation? Okay, what is the notation to create a list? So the notation is square brackets. This is the notation. We use square brackets to create a list. So if I want to create a group of objects, I should put these values inside these square brackets like this. If I want to store some numbers, so let's store 10, 20, 30, 40, 50. So if I want to store these numbers, I should put all these values inside the square brackets, and I can give the variable name. Let's give it numbers, and then we can put this equal to symbol in between these two, and then the list is created. The notation here is the square brackets. So this is very important because for each collection data type we will use different types of notation. So for the list, the notation is square brackets. Okay, what is the notation? It's square brackets. So the notation is square brackets. We need to put all the values between these square brackets, and then the list will be created. So the numbers is the variable. Now if I print the type, so now if I print the type of these numbers, you will get class list. Okay, now if I print type of numbers, then I'll get class list in the output screen. Okay, so list is a data type. It is a collection data type that we use to store a group of objects, and the notation is square brackets. Now we'll see some characteristics of list. Okay, there are some characteristics that we should learn. So the first characteristic, okay, the first important characteristic is that in list duplicates are allowed. We can store duplicates. What are duplicates? So in this example we took 10, 20, 30, 40 and 50. So duplicates means I can take this 10 so many times. I can take this 10 3 to 4 times, and it is not same. For example, in a classroom we could have 2 or more students with the same name. So if we want to save them, then the names are nothing but duplicates if I have 2 or more people. So if we want to store marks of a student, maybe some students would have got similar marks, then we have to store them in a list. Then these are called duplicates. So the first characteristic is duplicates are allowed in the list. So I can write duplicates are allowed. Example, I can take this 10 so many times, and I can take 20 2 times, I can take 32 times, and 40 and 50. So this is how we create a list, and inside the list we can use duplicates. And the second characteristic, second point is, the first is duplicates are allowed, and second is order is important. Order is important. So what is meant by the order in a list? So when I create a list, I'll insert the list in a particular order. When I'm writing a list, first here in this example, first I inserted 10, then I inserted 10 again, then I inserted 10, then I inserted 20, then I inserted 20 again. So we are inserting in a particular order here. So when I'm printing the list, the same order will follow. In which order I inserted the elements inside the list, the same order will follow when we are outputting the list. So when I print this list, when I print these numbers here, then the same order will follow. For example, if we take this particular list here, if I take this list, the first is 10, second one is 20, third one is 30, 40, 50. So when I print the list, the same order will follow here. First 10 will be printed, 20 will be printed, 30, 40, 50. We will see all these in a program in a bit, after writing down all the characteristics. So I can say that order is important in list. In which order we insert the element, the same order the list will be printed here. So this is the second characteristic, and the third one is heterogeneous objects are allowed. So what is meant by heterogeneous objects? So heterogeneous objects are nothing but different data types. So we can, in our above example, we have stored only numbers, but like all the elements in the numbers list that we created here, so all these elements are integers, but we can also use different data types in one list. So let's take any number like this. Let's name this variable name L and try to insert some elements. I inserted 10, 20, 20, and then I want to insert a name here. Then I want to insert another name. Then I want to take a float number, 2.45. Then I also want to take a boolean. So here I inserted integer here, then I inserted two strings, then I inserted a float, then I inserted a boolean. So in like heterogeneous objects are nothing but different type of object, okay, different data types. So in a list we can take different data types at a time in one single list. So it doesn't matter if we can use any data type inside a list, so which is nothing but heterogeneous objects. There is another kind of objects just like these called homogeneous objects, which means same kind of data. So in C language and in Java, we use the concept of arrays, and inside the arrays we can only store homogeneous objects, which means the same type of data. But here in the list we can store different types of data in a single list. So these are the main important three characteristic of the list. So the definition is, if you want to store a collection of objects while using a single variable, we'll use list. This is the notation, the square brackets, and these are the characteristics. Okay, so these are the characteristic. List allows duplicates, order is important, and heterogeneous objects are allowed. And the fourth point, I can also write list is growable in nature. So why did I write this one? What is the meaning of growable in nature? So the meaning of growable in nature is we can the list can actually expand. So if I declare the list using 5 elements, then it can get expanded. We can add new elements, we can also update it, we can also delete it. So it is growable. We can also reduce the list. So we will so list is growable in nature. So list is growable in nature. We have two methods that I am going to discuss now, append and remove. So the meaning of growable is we can actually expand the list. So we have append function inside the list, which is used to add elements, add new values. So if I have a list, so if I have a list like this, the same list, I'm going to take the same list that we took in our previous example, 10, 20, 20, 30. So this is a small list, and I can use the variable name and put a dot symbol here, and then use this function append. Inside the parenthesis of this append function, I can add the new value that I'm going to insert. So when I insert this, so the definition is add new value, and the new value will be added to the last in the last location of the list. So I'll write it down here. So the new value will be added in the last location. So now after appending this 40, if I print these numbers, then I'll get these, yes, now I'll get this output. 10, 20, 20, the order is important, so it will be printed in the same order, and the 40 will be added in the last location. So the 40 will be added here. This is the new value that we appended here. So what is the meaning of append? To add new values, and the new value will be added in the last location of the list. So we have another method, which is remove. This will use to delete a particular object. So we have to mention the element that we are going to delete here. Use it to delete a particular value. So we'll take the same example here. Numbers is equal to, so after appending 40, we have 10, 20, 20, 30 and 40. So now I want to delete this 20 here. So I'll just write the variable name, I'll put a dot symbol, then I'm going to use this remove function. Inside the parenthesis, I'm going to write the element that I'm going to delete. I'm going to delete 20. Now I'm going to remove this 20. After removing it, if I print these numbers, then I'll get the following output like this. So 10, we will only have 120 now because we deleted the 20 here. So so 10, 20, 30, 40. So this is the output after deleting the 20. So which is the reason I say that it's growable in nature, because we can add elements, we can remove elements. So this is another characteristic. And what happened here? Yes. So these are the 4 characteristics that we discussed. I'm going to add one more characteristic here. So we say that it's growable in nature. So so getting back to this example, so after I created this numbers list, so can you tell me how to access these elements, how to print a particular element inside the list? If I print numbers, then the output will be the whole list. Okay, the whole list will be printed. Okay, 10, 20, 30, 40 and 50. But if I want to print a particular element, I want to print 30 for example, then how do I do it? For example, I want to print from 20 to 40. I don't want to print 10 and 50. I want to print 20, 30, 40. I only want to print these 3 elements. So how do I print it? So here comes the concept of indexing and slicing. So I can say for list, indexing and slicing is applicable. We will discuss what indexing and slicing means. I think we already discussed indexing and slicing in strings concept. The same thing applies here. Indexing and slicing are applicable for list. So indexing or slicing are applicable for list. So for example, if I here 10, 20, we have 10, 20, 20 and 30 here. So this is the list that I created. Here also we created the same list. So if I want to print this 30 now, I want to print this particular element. So what should I do now? So I'm going to use the concept of indexing. So we all know that we have both positive and negative indexing in Python. We discussed this in the strings. The same concepts applies here. First I will draw this list. So we have 20, 20 and 30. So the index starts from 0. This is 0, this is 1, this is 2 and this is 3. And we also have negative indexing in Python. Negative indexing will start from right to left. So and it starts from -1 because 0 is already fixed here. So it will start from -1. This is -2. This one is, it will start from right to left. Positive indexing starts from left to right. Okay, positive indexing will start from left to right. Negative indexing will start from right to left. So this is -4. So now if I want to print this, what will I do? I'm going to use the print function here. So I'm going to use the print function, then I'll use the variable name numbers, then I'll use the square brackets. Then if I want to print 30, okay, for example, if I want to print 30, then what is the index for this one? Index is 3. If the index is 3, then I'm going to put the index here. Okay, then I'm going to put the index, then the 30 will be printed here. So we can print the elements using we can access the elements using the index concept. The positive indexing starts from 0 and negative indexing starts from -1, and it will start from right to left, and the positive indexing will start from left to right. So if I want to print this 20 here, which index should I use? I should use index 1. Let's write the code for this one too. So I should use the print function numbers. Okay, I forgot to use s here. Numbers, then I should use index 1 so that I can get the 20 here. So this is how the indexing concept work. Let's also see how to use this concept of slicing here. So if I want this 20 and 20, okay, I want these two elements to be printed here. So what should I do now? I can use the slicing concept. We all know that we can slice a particular string. We discussed that in the string concept here. So we can actually use the concept of slicing, and it goes something like this. Okay, we should put the starting and the ending index inside square brackets. Start, and I should put colon here, and I should put the last index. Now it will print from start to n minus 1. So if I mention starting and ending index, it will print from starting index to n minus 1 index. Okay, let's take an example here. So if now I want to print this 20 and 20, okay, I want to print these two elements. So what should I do? I should start with the starting index will be 1. So I'm going to write the code. Print numbers, put the square brackets, and in first I should put the starting index, which is 1, and then I should put the end index. So if I want this 20 and 20, the starting index is 1, and what is the ending index? 2. But based on our syntax, it will print to start to n minus 1. So I should write 3 here. So if I write 3 here, then it will be printed from 1 to 2. So it will print from here to here, 1 and 2, because we included 3 here and 3 minus 1 is 2. So it will include 1, it will include 1, and it will include 2 here. So 1 is 20 is 1, and the next 20 is 2, and the output will be 20 and 20. This will be the output here. Okay, so this is how this slicing concept works. Okay, I forgot. Okay, why did I put comma here? I should put colon here. Sorry, I'm extremely sorry. We should add colon here, so it will print from 1 to 2. So this is how indexing and slicing works in Python. These are the characteristics. Okay, growable in nature, and indexing and slicing are applicable for the list. And the last and very important characteristic that I want to discuss here is that list is mutable. This is very important, okay, because we have discussed what mutability and immutability means in our previous lectures. So I can say that list is mutable. What is meant by mutable? Mutable means changeable. We can change the content of the list. Okay, I can change the content, I can change the values, I can update the values. So the meaning of mutable is changeable, which means we can change the values. We can change the values inside the list. We can delete the values too. And we can add new values. So it's nothing but changeable. Okay, changing means deleting, adding, updating. Okay, we can add new values, and updation is also possible here. Okay, updation is nothing but changing. So mutable means changeable. Okay, if you are able to change the content inside the list, then it is nothing but changeable. But we discussed that the fundamental data types are immutable, which means that we can't change it. But list can be changed. Okay, because list is mutable. Let's take an example again. Numbers is equal to 10, 20, 30, 40, 50. So I want to change this. I want to change this particular value 20. Then what can I do? I can use the index. We all know that 0, 1, 2, 3, 4. I can simply use the indexing concept here. Just write the variable name, and inside the square brackets write the index number and equal to, and then change this value. Then when you print the numbers again, then you will get this list here: 10, 777, 30, because the index number 1 is being changed to 777. This is the updated list because we have updated the value using the index. So the same applies, just because it is immutable, if you can observe, we can actually grow it. Okay, if it's mutable, then we can append new values here. We are able to add new values, we are able to remove it. Okay, when we are able to add, when we are able to delete, when we are able to update, then it's nothing but changeable, which means list is mutable. So this is the idea, the basic idea of list. In the upcoming lectures, I'm going to make a separate video on list and dictionary to discuss more methods and to discuss in more detail, and we will also do some more examples. But we'll discuss so many methods which are applicable for the list. So this is just basic idea. So these are we have discussed the characteristics here. Duplicates, ordering is important, heterogeneous objects, growable in nature, indexing, slicing, and we also discussed that list is mutable, which is very important. Okay, mutable means changeable, which means that we can change the values like this. So I changed 20 to 777, so that the 777 is being updated. Okay, so now we will get into the concept. We will start the new data type, which is tuple here. So tuple. So I told you that we have these are the main data types: list, tuple, set, dict, and frozen set. These are the, I could say, the main collection data types that we in Python. So we completed list. We will start with tuple now. Okay. So tuple, the same definition goes for tuple too. If we want to store a group of objects, then we will use tuple data type. So the definition is same. If we want to if we want to store so the definition is same. If we want to store a group of objects, then we will use the tuple data type. So let's see how to create a tuple. So what is the notation for the tuple? So for the list, so we will see. So for the list, what is the notation for the list? The notation for the list is square brackets, and the notation for the tuple is open brackets. Okay. So this is the notation for the list. Open bracket is the notation for the tuple. Let's write an example. If I want to create the same list that I created for the list, I can use numbers variable, and then I'm going to use flavor bracket. What did we do for the list? We used square brackets for the list, but for the tuple we are going to use open brackets. 10, 20, 30, 40, 50. So this is how we create a list in Python. We will use the open bracket. So now let's try to understand the characteristics of tuple. So I'll only say one statement here. With this one statement, you should understand the meaning of tuple. So the one statement is that tuple is exactly same as list. Okay, this is the very important statement for a tuple data type. Tuple is exactly same as list, but there is only one difference in tuple. So the only one difference is that tuple is immutable, which means we can't change the content inside the tuple. But going back to list, what is list? List is mutable, which means we can change the content in the list, but in the tuple we can't change the content. That's the only difference between tuple and list. So I can write this statement here. What is the statement? Tuple is exactly same as list. Everything is same. Okay, all the characteristics that we discussed in list are applicable in tuple. But what is not applicable in tuple? tuple is immutable, which is we can't change the content inside tuple, but we can change the content inside list. So tuple is exactly same as list, except that it is immutable. Okay, this is the only one and only difference between list and tuple. So I created numbers is equal to 10, 20, 30 and 40. Now let's write the characteristics. Okay, all the characteristics are, to be honest, all the characteristics are same. Okay, we don't need to write it again, but I just want to write it because all the characteristics of list are applicable for tuple. So I'll just write in a shortcut format. Are duplicates allowed? Yes, duplicates are allowed. Is order important? Yes, order is important. Then what's the other one? Heterogeneous objects are allowed. Yes, heterogeneous objects are also allowed in tuple. Heterogeneous objects are allowed in tuple. What's the other one in the list? Indexing and slicing is applicable. Yes, indexing and slicing is applicable in tuple, because that's how we are going to access the elements inside the tuple. So these four, whatever is applicable in the list, it's also applicable in tuple. So indexing and slicing is applicable in list, it is also applicable in tuple. So what's the basic difference then? The basic difference is tuple is immutable. Okay, this is the basic difference. So when I say that tuple is immutable, can I say, okay, let's get back to the characteristics of list. Okay, what are the characteristics of list? The one I discussed here. List is growable in nature, and I also discussed two methods here, append and remove. So now when I said that tuple is immutable, which means we can't change the content, can you say that is tuple growable in nature? I'm saying that tuple is immutable, which means that we can't change the content inside the tuple. Now can you tell me, can I say that tuple is growable in nature? Can I say that? No, we can't say that. Why we can't say that? Because when we say that it's growable, when we can add elements, when we can delete elements, when we can update the values, when I can't change anything, when I said here that tuple is immutable, which means that it is non-changeable, how I can add new elements? So if I can't add new elements, can you say that are append and remove functions applicable for tuple? Can you say that? Can you say append and remove are applicable in tuple? No, it isn't, because append is used to add new elements. When we can't change anything, how can we add new elements? When we can't change anything, how can we delete new elements? So these two methods, okay, these two methods are not applicable for tuple. This is the only difference, the concept of immutability. So when it is immutable, then how can I say that these two methods are applicable for tuple? So these two methods are not applicable for tuple, because tuple is immutable. What is meant by immutable? It is not non-changeable, which means we can't change it. Immutable. Okay, so now I can write here, duplicates are allowed, order is important, heterogeneous objects are allowed, indexing and slicing is allowed, tuple is immutable. So these are the characteristics of the tuple. So all the characteristics are same as list. The only difference is that in tuple we can't change the content, and in the list we can change it. And indexing and slicing are also allowed in tuple. We can use the concept of index to print the elements. We can slice it. Okay, we can slice apart and then print it. So now we will write a program, and then we will see all these characteristics in a program, then you'll be able to understand in a better way. So now we are going to see a program based on all the characteristics to define all the characteristics that we discussed for the list and tuple. So what are the characteristics that we discussed for a list? What is the first one? The first characteristic is duplicates are allowed, and next I discussed order is important. Next, heterogeneous objects are allowed. Next, I told you that it's growable in nature, and I told you that indexing and slicing are applicable. And I told you that list is mutable. What is meant by mutability? Mutability means we can change the content. We can change the content. So these are the characteristics that we saw here. We will write a program and see if all the characteristics that we discussed works or not. Let's try to create a list 10, 10, 20, 20, 30, 30, 30, 40 and 50. So here I'm including the duplicates here. We have included 10 2 times, I've included 22 times, I've included 33 times, and we will also see if the order is important or not, because I inserted this list in this particular order. The first element will be 10, and the second element will be also 10, and the third element will be 20. We will also see when we print these numbers, we will see if these numbers will be printed in the same order or not. Now let's try to print numbers and see if the order is applicable or not. Yes, the order is applicable. First 10, 10, 20. How? In the same way that we inserted here, the same way we got the output. So duplicates are allowed and the order is important. Now let's see if we can include heterogeneous objects, which means if we can include different types of data here. Let's take L. L is equal to 10, 10, 20. Let's write my name here as a string. Then Hyderabad, it's a string. Then let's put a float number like this, and let's also put a boolean value here. So if I try to print L, we will get all these elements here. So 10, 20, we also got the string, we also got the float, we also got the boolean type here. So heterogeneous objects are allowed. Let's see if it's growable in nature and if the indexing and slicing are applicable or not. So let's see if indexing and slicing concepts are applicable. So how I want to access this element? If I want to access my name, this string, if I want to access this string, I should use the index. So index starts from 0. The first index is 0, the second index is 1, and the third element is index. The first element is at index 0, the second element is at index 1. So let's try to print the second element here. I should use the print function, then I should use the list name here, then I should put the square brackets, then I should put the index number here. If I do that, then I'll get the output here. I hope you can see the output here. So this 20 is the output. Then I can let's try to print L of 0, 1, 2, 3, 4, 5. Let's try to print this fifth index, then I'll get true here. So indexing is applicable. Let's also see if this slicing is applicable or not. So what is the syntax for this slicing? First I should put the variable name, and inside the square bracket first I should put the start index. So if I want to print these two elements, which is 0, 1, 2 and 3, I should print from 2 to 3. Then what should I put? First I should put the start index, then I should put the end index, but while printing it will print n minus 1. So if I want to print from 2 and 3, I should put 2 as the starting index, but I should put 4 here, so that it will print from 2 minus 3. Sorry, it will print from 2 to 3. So it will print from start to n minus 1. So if it's n minus 1, then it will print from 2 to 3. Now okay, I didn't close this one. Okay, I should write this again, I guess. Print L 24 type error, list indices must be integers or slices, no tuple. List indices must be integers or slices, no t tuple. 2 4. Okay, so we should put the first starting index, and then we should put the colon, and we should put the 4. We should close the square bracket, and we should put the open bracket. We should close the open bracket. Why did we get an error here? Because we used comma here. We should use the colon here. We used comma, so which is the reason we got the error. So now if I print this, we got the output here. So indexing and slicing is also applicable. Let's see the two methods that we discussed. We discussed append method and remove method. So first of all, what is meant by a method or a function? Okay, a function is something which does an action. So if I'm a human, then what actions does humans do? Humans will walk, humans will eat, then walk is an action, then eating is an action. So at the same time, what action does this append function do? Append will add an element to the end of the list, and remove will remove a particular element in the list. So if I want to remove, let's create another list here. So to 10 20 30, I executed, and first I want to print this. So now I want to add it. So if I want to add it, I should write the variable name, I should put a dot, and I should use this append function, and inside this flavor brackets I should give the value that I am going to add here. I am going to add 40 here, then I should put the 40 here, so that it will get executed. Then if I print this number 3 again, then I'll get the list 10 20 30 40. Now I want to delete this 20 from this list. So what can I do? I should first write the variable name, I should put a dot, and I should write the remove function, and inside the parenthesis I should write the number which I want to delete. I should write the object, or I should write the value which I want to delete from here. I want to delete 20, so I will write 20 here. If I print this numbers 3 again, then I'll get this, the 20 is removed. So now can I say that list is mutable? Because we are able to do everything. Okay, we are able to add an element, we are able to remove an object or element, we are able to, what can we do? We are able to change it. Let's also see how we can update the value. Numbers of 3 index, I want to update 40 to 777. So what is the index of this 40? 0, this is 1, this is 2, so I should put 2 here, then I should equal to symbol, then I should put 777 here, then it will get updated. So that I can, so now I can update it, I can add, I can remove, I can do whatever I want, I can change the content. Then list is mutable, which means what is meant by mutability? Mutability means changeable. So this is all about the list. We just wrote a program and saw that all the characteristics works here. So now let's go with tuple. So I told you one statement for tuple when we discussed tuple. I just told you one statement which defines the tuple data type here. So the statement is that tuple is exactly same as list except that it is immutable. Tuple is exactly same as list except that it is immutable. What is meant by immutable? Immutability means I hope the spelling is correct. Okay, immutability means non-changeable, which means that we can't change the content, which means we can't change the content. Let's see if it is valid or not. So I'm going to see if all the characteristics of list works in tuple or not first, and then we will see if immutability concept is applicable. So 10, 20, 30, 40, 50. So what are the characteristics of list? Duplicates are allowed, order is important, heterogeneous are allowed. Let's see if these three characteristics works for tuple as well, because I told you that tuple is exactly same as list except that it is immutable. So everything in list should also be applicable in the tuple. So that's the reason I took duplicates, and let's see if duplicates work in tuple or not, and let's also see if the order is important or not. Print of number 6, then I'll get the output. So yes, in tuple the order is important and duplicates are also allowed. Let's also try to print the type of number 6. So you got tuple here because we used open bracket notation, which is the reason this is tuple. If you use square brackets, then the type will be class list. So these three characters are allowed. Now let's see if indexing and slicing are applicable not for the tuple. So numbers of 6, index 0. Let's use the print function. Yes, it is applicable. Indexing is also applicable. Let's also see if slicing is applicable. Number 6, what is the syntax? First I want to print 20, 20 and 30. So 0, 1, 2, 3, 4. So I want to print from 2 to 4 index. So first I should put 2 here. Then if I want 4, then I should put 5 here. Okay, I should put a square bracket here. Now I'll get the output 20, 20 and 30. So I got this output. So indexing is applicable. Indexing and slicing are applicable here. So what is the difference then? So the only difference is that tuple is immutable, which means that we can't change the content, which means we can't actually update these values. We can't add new values. We can't remove any element from this tuple. So if it's immutable, if we can't change the content, do you think tuple is growable in nature? It is not, because we can't add new things, we can't change anything. So how can we say that tuple is growable? We can't say that. So tuple is not growable. So now if I'm going to update the value, let's see what we'll get here. We'll get an error. Tuple object does not support item assignment. It does not support assignment. We can't add any new values. We can't delete new values. We can't delete the values in the list, and we can't update the value too. Let's see if the append and remove function is applicable for tuple. Let's append T9. So I'm going to append 8,999 to this number 6. Let's see what happens. We'll get an attribute error. Tuple object has no attribute append, so it does not have any attribute called append. Let's also try to remove. What shall we remove? What do we have in the number 6? Let's try to remove this 50. So we again got attribute error here. Tuple object has no attribute, remove. So why these attributes are not allowed in the tuple? Because tuple is immutable. We can't change the content in the tuple, but in the list we can change the content, which is the reason we have these two methods. And in the list we also have some other methods which we are going to discuss in the future lectures, but the main concept that we need to understand here is that list is mutable, tuple is immutable. This is very important because this is the only difference between a list and the tuple. So we just wrote a program here. I hope you understood the both concepts, the list and tuple. So now we are going to see the other two data types today. We already saw list and tuple. We will see set and frozen set now. So this is the set, a data type. Okay, the definition of the set is similar is also similar to the list and tuple. We are going to store a collection, we are going to store a group of objects inside, like using a single variable. See, all the collection data types are the same. Okay, we are going to store a group of objects, unlike fundamental. So the idea of set is that, so in list, okay, if I want to write here in list, I told you that duplicates are allowed. Duplicates are allowed in the list, and even in the tuple duplicates are allowed. So even in the list duplicates are allowed, in the tuple duplicates are allowed, which means that I can store like this. I can store many numbers as many times as I want. So which is nothing but duplicates. This triple 10 are duplicates. But if you want to represent a group, of items where duplicates are not allowed and order is not important, then you should go for the set data type. So if you want to use where you are not going to include any duplicates, okay, you are going to include it once, okay, even though if you take the duplicates, it will be treated as one element. If you take 10 three times, it will be treated as one. So here, if you see the definition here, so if you want to represent a group of variables where duplicates are not allowed and order is not important, then we should go for a set data type. So this is the definition here. So unlike list, the duplicates are not allowed and order is not important. So what's the notation for this one? So what is the notation to create a list? First of all, what is the notation to create a list? It was square brackets. For tuple it was open bracket, but for the set it is flower bracket. So you need to put all the elements inside this flower bracket to create a list. So if I want to create numbers, I should open this flower bracket and I should include all the elements here, 10, 20, 30, 40. Then I can close the flower bracket, and if I print this, I'll get the output. Okay, so duplicates are not allowed. So even though if I write like this, if I write 10 10 20 20 30 30 and 40 40, but when I am outputting the set, it will be outputted like this. Okay, the duplicates will be treated as one duplicates. Okay, it will be outputted like this. 220s will be output as 120, 330, 230s will be of 130, 240s will be treated as 140. So this is what we will get as the output. Even though we can include the duplicates, while printing it, Python will be consider only one element. Okay, even though we include the duplicates. What about the order? So here, if you can see that we included the order, we included in this particular order. First we included 10, then we included 20, then 30, then 40. But when I print this one, when I print numbers, then the order is not guaranteed. The output can be in this way, 4, 30, 20, 10. The output can also be like this, 30, 40, 20 and 10. So the order is not guaranteed. Unlike list, in list order is guaranteed. Okay, order is preserved, but in set order is not preserved. If you insert some elements, then there is no guarantee that the elements will be printed in the same order. Okay, there is no guarantee for that. So what are the characteristics for the set? Duplicates are not allowed, order is not important, and heterogeneous are obviously allowed. For all the collection data types, heterogeneous objects are allowed. Even for the dict, for the frozen set, tuple, list, heterogeneous objects are allowed. So in list, duplicates are allowed, but in set duplicates are not allowed. In list, order is important in the list, but in the set order is not important. Heterogeneous are allowed in both list and tuple and also set. And the next characteristic is indexing and slicing. Is it applicable or not? Indexing and slicing, is it applicable or not? So can you tell me one thing now? So can you tell me, if the order is not important, if we have no idea what order the set is going to be stored, then how can we say the index? Okay, can we say that this element will be at this particular index when order is not important? So if you go back, if we go back to this example 10, here we have 10, 20, 30 and 40. When we printed, 40 is in the first location here. If we print it again, then 30 might come into the first location. Order is not at all important. If order is not important, then how can we represent these elements using index? Because at index 0, when we inserted it at index 0, we have 10, but we printed it, we have 40 here. Again, if we printed, we have 30 at the index 0. So at one particular index, we have different types of elements. So hence we can't use indexing. If we can't use indexing, then we can't use slicing too. So we can say that indexing and slicing are not applicable for set, because the order is not important. If the order is not important, then indexing, slicing are not applicable. Indexing and slicing is not applicable. And the other characteristic is it is growable in nature. Just like list, we can add elements. So if it is growable in nature, can you tell me if it's growable in nature, is it mutable or immutable? Can you tell me? It is growable, which means we can add, we can delete. Can you tell me if is it mutable or immutable? Obviously it is mutable, because we can add new elements, we can delete, we can change, we can do whatever we want. So it is mutable. Mutable means changeable. So these are the characteristics. Okay, duplicates are allowed, duplicates are not allowed, order is not important, heterogeneous objects are allowed, indexing and slicing are not applicable, because order is not applicable. If order is not applicable, then indexing is also not applicable. Okay, indexing is also not applicable. It is growable in nature. If it's growable in nature, which means it is mutable, which means that we can change the content. So if it's growable in nature, then we can add and delete elements. We will see two functions here, just like we saw in the list. So what does this add do? What does this add function do? So it will add new elements or objects. Remove will delete a particular object. So if I create numbers list 10, 20, 30 and Vikas, we can use heterogeneous objects. So if I want to add new element, I can use the same method that we used for the list. I should mention the variable name. I should put a dot here. Then I should use the add function, and then I should add an element here. And the same goes for the remove function. If I want to remove 30 from this list, then I can just put numbers dot remove, and inside the parenthesis I should put 30 here. Then I can delete the 30. So now add and remove, these are the two methods in the set. So now let's talk about the differences between append method in list and add method in set. Because we used append method inside list, then now we are using add method in set, then there should be a difference, or else we can just use the same thing. If we are using a different method for set, and if we are using a different method to the list, then we should see the differences between these two methods. So the difference is that if you know that, like if you remember it, in list order is important. So if you know the meaning of the append function, if you know the functionality of it, whenever you insert a new element, it will be added at the end of the list. So if I have a list like this, if I want to add 30 to this list, then it will be added at the end. Okay, it will be added at the end. That's the basic idea of append. Okay, I can say that the element will be added at the end, will be added at the end. But in the set, the order is not at all important. So when even though we insert the element, it won't be added at the end. It can be added anywhere because the order is not important. So that's the reason we are using a different method here, because if you're using the same append method, then it will be added in the end, which is violating the characteristic of set, that is order is not important. So which is the reason we created a new method called add. Like the Python people created this method. So the order is not guaranteed. If we add new element, there is no guarantee that it will be added to the last. It will be added to the end. So this is the difference between the append function in the list. So this is in the list and this is in the set. So these are the characteristics for the set data type. So duplicates are not allowed, order is not important, heterogeneous are allowed, indexing and slicing are not applicable. Because order is not applicable, then indexing and slicing is also not applicable here. Growable in nature, we saw two methods here, add, and we also saw remove method here. Okay, and it is mutable. Obviously if we can add and remove elements, then set is obviously immutable. So to revise it, list is mutable, tuple is immutable, set is mutable. So I think that's all about the set data type. Now we will look at the next data type, frozen set. And here I'm again going to tell you one statement again, just like I told you in the tuple. I'm going to tell you one statement here for the frozen set. So the statement is frozen set is exactly same as set except that it is immutable. I'm going to write this statement here. The statement is frozen set is exactly same as set except that it is immutable. We know that set is mutable, so frozen set is immutable. Except that frozen set is immutable. This is very important. Okay, this word is very important in frozen set because that's the only difference between set and frozen set. So can I say, let's write down the characteristics. Are duplicates allowed in frozen set? Are they allowed in the set? If they are not allowed in the set, then even the frozen set it's not allowed. Order is not important. Yes. Heterogeneous are allowed. It's allowed in the list, so it's also allowed in the frozen set. Is it growable in nature? It's not, because frozen set is immutable. If it is immutable, then we can't change the content. If we can't change the content, then it's not growable in nature. Is indexing and slicing are applicable? No, it is not applicable. Indexing and slicing also not applicable. Because order is not important, then indexing and slicing is also not important. So how do we create a frozen set? Okay, we used to create, let's tell you this again. For the list we use square brackets. For tuple I use open brackets. For the set I used flavor bracket. Then how do we create a frozen set? So we create frozen set using a frozen set function. We don't have any particular notation here. We are just going to use frozen set function here. Oh, I'm sorry. we are just going to use this frozen set function. So first I should create a set. Using the flower bracket notation. 10, 20, 30, 40. This is a set. Then I should pass these numbers into this frozen set function. Frozen set of numbers. Then I should assign this to a variable here. Let's take fs. Now this fs is frozen set. Okay, so this is the only difference between frozen set and set. In set is mutable and frozen set is immutable. Other than that, there is no other difference. So now let's try to program and understand the characteristics of set and the frozen set. Okay, now we will write a program to understand the characteristics of set and frozen set. So what is the definition that we discussed in the set? If we want to store a collection of items or collection of objects, I can also say values where duplicates are not allowed and order is not important. So this is the definition that we used for the set when we want to store, if we want to store a group of objects where the duplicates are not allowed and the order is not important, then we will go for the set data type. Let's try to create a set here. Numbers, I'm going to use flower bracket notation. For list it's square bracket, for tuple it's open bracket, for set it is flower bracket. So 10, 20, 30, 40. I can also use heterogeneous objects. Let's print numbers. Let's also print the type. We got set here because we are using the flower bracket notation here. So now I want to show you what happens when we try to store duplicates. So here I'm trying to store duplicates here. So now the code is working, but when we try to print it, we will only get this once. And can you see here, the order is not important. In the both cases we inserted 10, 20, 30, 40, but when we tried to print it, first it was 10, then it is 4.56, where when we inserted the 4.56 is to the end, but when we printed it, the 4.56 came to the second position in the set. And the same happened here. 40 I inserted to the end, but 40 came to the first position in this set. So duplicates are not allowed, even though we are inserting duplicates here. When we are printing it, the duplicates are not being considered. And when I inserted 40 in the end, when I printed it, 40 is being printed in the first position of the set. So here duplicates are not allowed and order is not important. So let's see if indexing concept is applicable or not. When order is not important, then indexing should not work here. I think you will get an error now. Yes, set object is not subscriptable, which means we can't use indexing concept. I think let me minimize it so that you can see. So now we saw if duplicates are allowed or not. Duplicates are not allowed and order is also not important here. So if order is not important, indexing doesn't work, so we can't help now. So now let's see if it's growable in nature or not. Let's see the two methods that we discussed here. So let's try to add to this numbers too. I'm going to add an element here. So what should we add? Let's add 50 here. And when I try to print numbers 2, let's see where this 50 will be added. So can you see the 50 is added at the third position, but in the list when we use the append function, we used to add the element to the end, but here 50 is added in the third position. It can be added anywhere, it doesn't matter. So order is not important here. So let's see if we can remove it. 2 dot remove 40. Let's try to print numbers 2 again. So we will not find 40 here. We only have 10, 50, 20 and 30. So add function is working, remove function is working. We saw that indexing and slicing is not applicable. We saw that duplicates doesn't work. So what else? Characteristic, it's growable in nature. Indexing and slicing also doesn't work. Okay, if I slicing and indexing, okay, if I want to access numbers of 0, you will get an error here. Set object is not subscriptable. Okay, we already saw here. And slicing also, slicing doesn't work too. If indexing is not working, then how can slicing work? So this is about set. Then we will see how to create a frozen set object. So first, for the frozen set, we know that we are going to use frozen set function here. So first we should create a set, then we should pass this numbers 1 into that frozen set function. 11, 12, 13, 14. This is the set. Then what I'm going to do is I'm going to use this frozen set function and I'm going to pass this numbers 1 set. This is a set. Okay, I will also print the type here. What happened? Okay, I understand. So now let's try to print the type of numbers 1, and now I got set. Let's now try to print the type of fs. Now we'll get frozen set here. So for this numbers 1, we created using the flower bracket notation, which is the reason we got class set when I tried to print the type of numbers 1. So here I created a frozen set here. I passed this set into this frozen set. Now this fs type is frozen set. So I told you one point that frozen set is same as set, except that it is immutable. What is the meaning of this? We can't add or we can't remove from this. So have created this frozen set. Let's see if this is working or not. If I want to add 40, it will not work because frozen set object has no attribute add. Let's see if I can remove it. What do we have in the numbers 1? We have, let's try to remove 11 here. So we can't remove it because frozen set object has no attribute remove. So frozen set is immutable, which means that we can't change the content, which is the reason we are getting this error. But in the set we can change it. We have add, we have remove, we have add and we have remove method. And so I think this is all about the characteristics of set and frozen set. So what we discussed today, in this lecture we discussed list, we discussed tuple, we discussed set, we discussed frozen set. So we completed 4 collection data types. We just saw the basic concept. Actually in the upcoming lectures I'm going to make separate sessions on list, tuple, set and dictionary. We will see what is meant by dictionary in the next lecture. We will see dictionary, we'll see bytes array, and also we'll see some other functions like range, and we will also see the data type none. In the next lecture we'll see that. So that's all for today. I'll see you in the next lecture. Have a nice day.